Today we're going to do another Algebra 2 review where we're talking about the inverse of a function. So the goal today is to be able to find the domain of the inverse of a function. So let's remind ourselves what an inverse is. So basically when you have an inverse, if you take a point x, y on any graph, then if I find the inverse, all I'm doing is switching those x's and y's. So if I take that point x, y, and then I find the inverse of it, I'm just going to have y comma x, and that's going to be on the graph of the inverse. So when I say f to the negative 1 of x, that means the inverse function. Okay, therefore the inverse of the graph of this function is going to end up reflecting over the line y equals x. Okay, so the inverse of the graph of f of x is going to reflect over that parent function, that linear parent function. And so if I look at a picture here, I have this original function, the blue function is y equals x squared, and if I was to take any point on this graph and I switch the x and y, I probably should pick a color that's not blue. If I switch the x and y of, let's say, 2, 4, so on my new graph, I'm going to have the point 4, 2. This was 2, 4. So on my graph of my inverse, I should have the point 4, 2. And so you can see that they are going to reflect over this linear parent function because that's basically what the inverse is doing. It's reflecting it around that line. So if you look at this guy, the inverse of y equals x squared, it's not actually a function, but it is an inverse. Okay, so let's talk about how we would find an inverse algebraically. So to find that inverse algebraically, you do the same thing you would do to the coordinates. You simply switch x and y, but then you need to go ahead and solve for y and your new function. Okay, so again, all we're going to do is switch x and y, and then we're going to solve it for y, and that will be the inverse of my function. The domain of f of x ends up being the range of the new function and vice versa. So if I wanted to find the domain of the inverse function, it's actually the range of the other one because you've just flipped x and y. So instead of having your domain be your x values, your range be your y values, it's just switched for your inverse. Okay, so if I want to find the inverse of this function, we're gonna switch x and y. That's the first goal here. So these two variables are going to end up flip-flopping. So I end up getting x equals 1/2 y cubed minus 4. Okay, now I have to solve this for y. So it's just like how you'd solve an equation before. We're going to go ahead, we add 4 to both sides. No, you can't add x and 4 together, so we're just going to have x plus 4 equals 1/2 y cubed. There was a late bus, that's cool. Then I'm going to go through, I want to get y by itself, so I'm going to multiply both sides by 2. And then I will have to distribute this 2, so technically you wouldn't have to right away. I'm just going to do it just so that way I can get it out of the way. I get that that's equal to y cubed because this 2 and this 2 cancel out. And now in order to get the y by itself, I'm going to take the cube root of both sides. So what I just found here, I found that the inverse function is going to be y equals the cube root of 2x plus 8. Note you can't take the cube root of 8 here because it's attached to the 2x. Okay, so the one thing that we want to make sure, I know it says y equals, we are going to flip that and make that say the inverse right here. The inverse function of this original function is that guy. So again, watch your notation. So now we found the inverse, cool. If I wanted to find the domain of the inverse, again, it's going to be the range of the original function. And because this is just a regular cube root function, that means I can plug in whatever number I want. And that makes sense here. I could plug in positives, negatives, etc. Oh boy. So then right here, so my domain for this one is, again, all real numbers because the range of the original function was all real numbers. And I also could look at the function and say I could plug in any x. Now there is one cool thing that has to do with what we did yesterday with the compositions. If you in fact have an inverse function of each other, if you compose those two functions, if you take f of g of x, they're going to equal g of f of x, so they're commutative, and then it's going to simplify down to x. So if those two compositions are true, then f of x and g of x are inverses. So really quickly, we're going to check our work on this one, and we're going to call this function, this one's going to be my f of x, my original is going to be my f of x, and my inverse is going to be my g of x. And we're going to take that function composition and make sure that I do in fact have inverses of one another. I didn't make a mistake. So again, when I plug in a composition of functions, all I'm doing here is for my g of x function, I'm plugging that entire thing into f. So instead of my x variable, I'm going to use the cube root of 2x plus 8. And then I cube it, and then I minus 4. So now I simplify this down. If I take the cube of the cube root, it just takes away that whole radical. Okay, that's going to give me, if I distribute that 1/2, that just gets me x plus 4 minus 4. My 4's cancel, so that composition became x. So that's looking like good news. We may have gotten it. When we take the composition and we get x, they should be inverses of one another. We're going to double check and make sure that g of f of x gets me the same thing. Again, wherever I have an x in my g function, I'm plugging in that entire thing. Okay? Sorry. So I'm going to be doing the cube root of 2, and then my x is now 1/2 x cubed minus 4, and then plus 8. Okay, again, I'm going to do some distribution here on the inside, kind of work on the inside out again. So I'd have 1/2 times 2 is x, just 1, so x cubed. 2 times 4 is minus 2. Nope, I can't. I just tried to half that. That's 8. Good thing I looked at my work before I kept going. 2 times 4 is 8, surprise. So these two things cancel. Negative 8 and 8 are going to cancel out. I get the cube root of x cubed, and so that's just going to be x. So hooray, congratulations, we did the inverse correctly. So again, when you take the composition of two functions, you have to have them equal to x in order for them to actually be an inverse of one another. The last thing we're going to talk about is something called a one-to-one function. A one-to-one function, when I say that, we know if a function is a function if it passes the vertical line test, if every x has one y. But if a function is one-to-one, then the inverse is also a function. So we've seen some functions that didn't end up, like the quadratic, the inverse was not a function. It didn't pass the vertical line test. So in a one-to-one function, not only does every x have one y, every y has one x. And it's going to end up passing what we'd call the horizontal line test. So you asked back in Algebra 1, maybe you didn't, but if you did, if it passes both the vertical and the horizontal line test, then we have a one-to-one function. So if I'm looking at this blue function right here, again, this is the quadratic parent function, and I do in the vertical line test, it's all good. Vertical line test, great. However, if I do the horizontal line test on this guy, I can see that it's failing miserably. At every point, there's two y's that go, or two x's that go with that one y. So if you look over here, this orange-red function is not actually a function because it wouldn't pass the vertical line test. I have lots of places where it's failing that vertical line test. So this right here is not a one-to-one function. So a quadratic is not one-to-one. The inverse is not a function. Now this funky thing over here kind of looks like a DNA strand. If you're just looking at the blue though, the blue is the graph x cubed. Okay, that's just the cubic function. And again, it passes the vertical line test because, you know, it's a function. We've said this a long time ago. And this blue function is good the whole way down. The blue is only ever touching this line once. So if I'm only looking at this green function, then I can see that that too is a function. And so this one, x cubed, is one-to-one. So basically, you can just perform the horizontal line test on any function, and it'll tell you whether that function is one-to-one. Okay, that's all I've got for you today. Hope you have a good evening.